Hey everyone, welcome back to the lab. In this video, we're going to be talking about how to stop wasting your time on bad startup ideas. So most startups fail, usually calculated at around 90% of all startups. A common cause is founders and builders spending lots of time and money building something only to release it and find out it's not actually valuable. Either no one wants it, or sometimes people want it, but no one wants to pay for it. Now, we previously discussed several ways to mitigate this build trap. That's what I call this. And how focusing on impact can prevent wasted resources across many dimensions. This post is around escaping the build trap the simple way. The build trap's kind of like that thing where you spend a lot of time building stuff, but like the thing didn't actually matter, wasn't actually useful. So how do we stop doing that? And this is more around like career advice. Like, what are the 3 tips I would give to someone to be a better software engineer? And the top one is always focus on impact, because I see this go wrong like so often. Anyway, back to the post. In this post, we're going to be exploring a useful mental model for startups and how we can leverage it to avoid sinking resources into bad startup ideas in the first place. Now, I want to call out that this post is heavily inspired by the mining metaphors, which I first read in this post. Don't build a mine before you struck gold. Some of the core ideas are the same, and I think this is a good post in general if you're interested in reading more about this metaphor. But I didn't find a lot of the takeaways as universally applicable as I wanted and thought the metaphor could go for. And so that's the different take that we're taking in this post, is really for builders in general, not just for like the CEO, but like the CTO, the engineers, the team leads, stuff like that. Okay, so let's dive into this metaphor. Startups as gold miners. The core metaphor is to think of startups like a gold mining expedition. So first we have our expedition. These are the people in the startups that are trying to profit. So obviously the founders are here. Maybe you have like a few workers already, probably have even some investors, like the people that allowed you to have the funds to like start on this expedition, gave you the food, gave you like the first shovel, stuff like that. So I think this metaphor goes pretty far, but we'll focus really on the founders in this post. Then you have the gold. And so this is the market you're trying to leverage. And this is like the key part of this metaphor, I think, like, right, we're the founders, we're the expedition, we're trying to go capture a market. We're trying to capture them, extract the gold, and eventually we're going to turn that into money that we want to use. And then mine and the mining, this is like the thing we're doing in order to get at that gold. Right, we're the expedition, we find the gold, but we need to actually mine it to get out of the ground, so that we can leverage that into turning it into whatever we want in the money. Now, I will say that this metaphor is a little bit extractionary, and I like to think of capitalism a bit more fair than that. I think we can do conscious capitalism where this isn't extractionary, and the way that I would change this metaphor is like, usually markets aren't non-renewable. Like gold is non-renewable, right? We know that like if we dig it out of the ground, it's not going to replace itself. The metaphor breaks down here because really markets typically are self-replenishing, and they're most self-replenishing if this capitalism that you're doing is a win-win for both. It's a win for y'all, the suppliers of whatever the value is, and if it's a win for the market, then they will keep coming and replenishing this thing. So a bit extractionary. I don't love it, but some people might think that's a better model of capitalism, but I don't. Anyway, thinking about it this way, there are 2 core phases required for the expedition, that's us, the founders, to successfully extract the gold, the market, the value. So the first one is looking for gold. You must find a place with golds before you can extract it, right? Like if we just started digging, there's no golds, can dig as much as you want, can't get any gold because there's just no gold there. And the second one is actually mining for gold. So once we find the gold, we have to get it out, and this is probably when we need to get it out efficiently so that we can make the amount of gold we're getting out, worth more than the effort we're putting in to dig it. Okay, and this leads us to the first, big takeaway from this, and really the core idea, and where we see a lot of people go wrong, which is you shouldn't dig where there isn't gold. So don't dig where there isn't gold. Thinking about it this way, it's pretty obvious that if we dig in a spot where there isn't gold, we won't get any. Worse yet, mining is quite expensive if we want to do it efficiently. But if we mine efficiently where there isn't gold, all we're doing is wasting our resources more efficiently. And so this is kind of like the premature scaling, the overreach of startups. Like, I think probably in the industry, this is like the most common killer of startups. And I think VCs often make this worse because they give you a bunch of millions of dollars and then you must get an astronomical valuation. And the only way that you could ever get that is if you start mining right now, huge operation, and it's all gold under you. That's very unlikely. And so I think it often turns like a small mining operation, if you will, that could have been okay if it stayed small and kind of expanded sustainably, into like a dead, bankrupt mining operation, pretty fast. Okay, so mining is expensive because there's a lot of things involved with actually doing the mining. So, you might want to build the mine, and this is like a lot of the startup equipment kind of costs, like the shovels, the mining helmets, all sort of stuffs like that. And then ongoing costs of like, the mine is caving in, we gotta like fix it. And then you gotta pay your workers. So the more workers you have, the more you have to pay them on a weekly basis. And then the more workers you have to provide supplies for them, the food, the shovels, maybe the computers, the subscription to like Adobe or whatever. And then the other key part here that I think is really, this metaphor really is good in a lot of ways, and this is another one that it gets right, is that it's hard to move. And I think people maybe don't think about this a lot when they're coming up with an idea. But basically, we'll read this here, and then once we've invested in a specific spot, we can't take all the holes that we've made to the next one. This makes many of these costs non-transferable. So like, whereas you could maybe take your shovels with you, and maybe you could take some of like the equipment that you bought, you can take your workers if you want. Like all these holes, all this stuff that you built together to flush out this one mine, a lot of it just isn't transferable to the next thing. And so this applies to all sorts of processes you might have put in place, all sorts of like software you built. A lot of it like is bespoke for the current problem you're trying to solve. So if you spend a ton of time building out this thing, like it might not transfer to the new problem or to the new thing. And so this is kind of like a sunk cost, like it can't be moved. Same with the mine. You can't take the holes with you. Even if you did, like it's not useful. Yet this is commonly what startups do. They find a spot and they build a mine, but there may not be any gold there, so it's destined to fail. How do we avoid this? In the same way that we would avoid building a mine where there isn't gold. To find a good mining spot, try to fail fast and cheap by invalidating sites that don't seem promising with the cheapest check. If it passes, we move on to more expensive and more rigorous tests. And I felt the need to explain this a little bit because this is fail fast, but I think a lot of times when people think of fail fast, they think of it not right. They're like, I'm trying to fail, I'm trying to do this. And that's true, but not all trying to fails are equivalent. There's like a good way and a bad way to do it. And the reason we're really trying to do this is because we're trying to cheaply invalidate our stuff fast before we invest in the mine, before we invest all these resources into something that's not good. And the reason that we do this is because it's actually extremely hard to prove anything is right, but it's very easy to prove something that is wrong. And this is like just the basis of science, basically. And so what we're trying to do is really do these experiments where we can fail really fast and cheap so that we avoid this long, expensive process of investing in something we think has been proven, but it's actually wrong. And so here's the steps for us to kind of do this mine. So the first is we got to survey your potential sites. Based on the land features and what you know, you may be able to pick some sites with higher probabilities of containing gold. I don't know anything about gold mining or geology or anything, so this might be totally wrong, but here's like my mental model of it, right? We're trying to survey some sites. Maybe we've got like 3 tiers. Green is for like it's good opportunity and it's pretty easy to access, so that's a good thing for us. Yellow is like, we haven't really heard anything about this area. We don't know if there's anything here, but like we can kind of access it, so maybe it's worth a shot. And then red is like bad. Like we totally know, maybe it's already been mined before, there's nothing there, or maybe it's just like impossible to reach. And so here's my little bad drawings in Excalidraw of like, some land features. And let's say that there's like a lake, right? And let's say maybe there is a spot in the middle of the water, but like it's so hard to get to, we're not going to drain the lake, so this is just a red, like bad opportunity for us. Now maybe we say like there's a spot next to the lake and it's really easy to access, there's like no trees or anything, but like it's next to a lake, like what are the odds that there's gold here? Maybe not that high. So we just give it a yellow. Might be something there. Let's say the same things with the forest, like could be some stuff here, but there's all these trees in the way, so it's not like super easy to access, so maybe it's just a yellow. And then we get to the mountain, which maybe has ore in it or not, I don't know. They have ore in it in the video game, so maybe it does. And so there's a lot of ore in the mountain, but we're like, there's some ore here, but it's like at the top of the mountain, we totally can't get up there, way too hard, let's not do that one. But then maybe there's some ore at the bottom of the mountain, we're like, okay, like there's some good signs here, it's pretty easy to access, this seems like a really promising place for us to find stuff. And so we're surveying all these sites very cheaply based on what we know to get some ideas of where to start, and then based on just a few things we know about it, maybe we can get rid of the ones we don't like and then have a few that might be promising. The next step is to sample those sites for gold, so we're going to sample our potential sites. And so we still need to check if they have gold, right? Like we have all these ideas, but like we don't know if any of them are true. We kind of have to like go disprove them, and if we can't disprove them, at least get some idea of like how much proof there might be here. And so we sample the ground with a few small deep holes and estimate what the opportunity is for the site. I don't actually know how people do this in gold, but I'm assuming they like dig a 6-foot thing that's like relatively fast to dig, but it's like a good chance of like seeing if gold's there. So let's just pretend that's how you do it. And so we picked a few sites that we might want to try, some of these like promising sites, and we do a few holes in the forest, and we're like, yeah, there's nothing here, so probably not worth doing. Maybe we go over here to the mountain and we like find some stuff, but like not as much as we expected and not enough to like make us feel like it's worth the investment. And maybe we come over here and we're like, oh look, this place actually has more than we expected, and it's not too bad. Not like a ton, but more than the other spots that we've had. And so now we have an idea of like not just which sites might be good, but what the actual data is showing us for like what's the opportunity here? Which ones might we want to start investing in more versus less? Okay, and now we want to mine with measured expansion, validating against estimates. So even if a site is promising, it might still be a dud. We balance our need to avoid ruin and want to maximize our upside through measured expansion of our mine. So as we go, measured expansion, and we want to validate our results against the estimates as we go so that we can course correct if we're wrong. And so here's an example. Let's say that we chose this mine because it had the best opportunity based on our samples, but remember, samples can always be wrong because, depends on your sample size, what's your statistical significance. So it's just always a chance that it's wrong. So we start digging, and maybe we start digging over here and it's like, oh man, there's actually nothing there. And so we need to course correct. We're like, maybe we don't dig over here. Maybe we start here and we're like, okay, this is actually really good. This is really good. Let's expand over here. Okay, less over here. Okay, bad. Now we need to course correct. And then we come back over here. And this is like how your mind will kind of grow organically. And we'll see a lot of parallels here with like how you should grow your product into this kind of like market. So even if we do this right, we're bound to come across a lot of duds and even start small mines at several duds. But that's just reality. There's a lot we just don't know, and thus we have to test it to find out what's actually there. This process is not easy, nor is it cheap, but it does limit the amount of resources we invest in these duds, which allows us to get to non-duds faster and with more resources available. Again, this is the fail fast idea where it's like we can't prevent our failures, but what we can do is we can catch them early, spend less on them, so that when we actually do find a non-dud, something that's actually worthwhile, we have the resources left over to actually double down and get the most value out of it. Okay, so that's the mine metaphor. How do we actually avoid bad startup ideas? So how can we apply this to the land of startups? So to avoid bad mines, what we did is we don't dig where there isn't gold. And so to avoid bad startups, what we need to do is we don't build where there isn't opportunity. So in the same way that most mining sites won't contain gold, most startup ideas won't be very good. But it's also true that we can't really know if a given site or idea is good or bad until we actually test it. We can and should utilize the data that we have available to us to estimate the potential of a site or market or idea to remove those that are very likely bad, but we can't do the same thing in the opposite direction. We can't really tell which are very likely good, because as we saw, the ones that we thought might be very good might just end up being middling, and the ones that we thought might just be good actually ended up our best option. So we need to test these sites and ideas to see how good they actually are. The faster and cheaper we can do this, the more likely it is we'll find a good one and still have the resources available to mine. And so I have this tweet here talking about the idea of small bets, and this is kind of what we're approaching with this metaphor and seeing kind of like what the meta game is for this. And the idea is that like timing the market is really hard, and so when you're trying to like find a mine just based on like your ideas, you're kind of like timing the market, right? Like it's like investing, timing the market. Maybe some people say they're good at it, but for the most part, everyone sucks at this. So what your best bet is actually to do is make small bets over time to increase your surface area of luck while avoiding ruin. So what we want to do is be able to increase our surface area of luck by digging as many holes as we can for as cheap as we can, as fast as we can, so that we've dug so many holes that our likelihood of finding a non-dud, of finding something with gold in it, increases by a lot. And this doesn't mean, this actually, it's still odds, right? So you might dig your entire life and find nothing, but the more holes you dig, the more likely it is you'll find something with something in it. So it's much better than the opposite of just like randomly digging based on what you think the market's about to do. And we'll talk about this more in a second, but my base heuristics of getting rid of the bad things that you definitely don't want to dig in is basically here. Like, what is a good small bet? And it's three things. One is the world needs it and hopefully will pay for it. The second is that you enjoy this work or are interested in the area. You wouldn't mind spending a lot of time here. And the third is that you're actually good at it. You can outperform most others. You're at least above average at this thing, because if you're not, then you're probably not going to win in this area anyway. And so we'll see this reflected as we kind of go from the mining steps to the startup steps and how they're related. Okay, so the first thing we want to do in the mining side is survey potential sites. And so the same thing for startup ideas. We need to survey our potential ideas. So the first step is finding ideas and trying to bubble up the most promising ones. Most of these ideas will be bad, but usually you need to go through a bunch of bad ideas for a few good ones to pop out and bubble up. And this is actually a pattern I've seen across like many different disciplines. And I have this post I wrote like a while back, like several years ago, which is basically my system of doing backlogs. Like these are project backlogs, right? And I use this for project backlogs. I use this for opportunities at work. I use this for ideas for startups. And And it's a very simple system, kind of like this. I have like thousands of ideas, and from those, maybe like, 100 are like good, but those thousands had to happen for the good ones to kind of bubble up. Read more about that there if you're interested. Okay, so once you have a backlog of ideas, you have to use some heuristics to try and narrow it down to several you think are useful to sample, because you can't just sample everything probably. Like, you probably don't have that much resources. And let's be real, we're talking about most of these are duds. So there's probably some heuristics you can use to at least narrow down the things to like get rid of the ones that are like obviously duds. So again, my go-to heuristics are: one, does the world need it and will they pay for it? Because you need it, the world to need it for any of this to matter. But if they won't pay for it, then also probably not sustainable. So you need both. Second one is, am I interested in this problem area and the work required? So personally, I think if you're not interested in the problem area, you're probably just going to burn out, not do a great job. Or if you're not willing to do the work required to win in this area, also probably not a good fit for you. So you might as well just like not even do it. On the flip side, if you really like this, then this could kind of make up for you're not super strong in this area, but this could be your strength. The third one is, am I good at this and well positioned to solve it? So a lot of people, they kind of talk about like unfair advantages. I think unfair advantages are good, but it's like very rare that you're gonna see something and you're like, I'm the perfect person for this. And I don't think it's really necessary. We see all the time people winning and they're like, anyone could have done that. It's not true. Not anyone could have done that, but I think more people could do it than you think. So I think what you should really think about is, am I above average in this area? Do I have the ability to become above average in this area? Or do the resources that I have around me make it so that I'm above average at being able to actually do this thing? And so this is the surveying thing and kind of prioritizing all the spots you might want to build a mine or build your business to capture this market. Okay, next is to actually sample those sites for their opportunity. So now that we have some ideas we're interested in pursuing, we now want to test whether they have any opportunity before investing in a full-fledged mine. So to do this, you should use small, cheap experiments, like talking to more potential customers about their problems, a la the mom test, and building MVEs, minimum viable experiments, to test problem, solution, market. So yeah, in the same way that when we're mining, we want to use these like really cheap holes to just kind of get an idea of what's in the area, but not invest so much. We want to do the same thing with all these ideas. And I think the first one recommend is definitely talk to potential customers about their problems. Like, if you need to use the mom test so that you're actually getting real data back from them and real information. But I think just talking to several people will give you such a much richer understanding of the domain area and what you're getting into, that as long as you're not biasing too much, you can self-reflect on the idea and probably find a lot of ways it's not optimal, and maybe either switch it up or just realize this isn't right for you. For more information on this, I really like and would recommend this book, The Mom Test. I refer back to it a lot. I think it's a great intro to like bias and how to actually avoid it, in a really simple, short book. So highly recommend this book. The next one is MVEs. I think, a lot of people talk about MVPs, but I don't like the term MVPs. I think it's very confusing. And I've talked about this a lot on Twitter, and I might do like a full post on this, but what you really want is a minimum viable experiment. How can you test this thing, like actually dig the hole in the cheapest way possible? So MVP, I think a lot of people go to like build full products because they don't have a good way to determine when is the product done, when is it like a minimum viable product. But when it's an experiment, it's all about, I'm trying to answer this one question. What is the minimum thing I have to do to disprove this? And when you're thinking about this, often it is like just talk to some people or do something that doesn't scale, like, I don't know, run an in-person training and see if people like have this problem. All sorts of other things come up with MVEs that MVPs just like aren't a good mental model for. And the last one I mentioned here is the problem solution market fit. A lot of people talk about product market fit. Again, I hate when people describe things as products because it's not both general enough to fit all sorts of other things that a product could be or that could be in that space, but also it's too generic to know when to stop. So what I like to talk about it as is the core components, which is the problem that you're trying to solve, the actual solution you provided, and the market that would need to use both of these. And if you have alignment here, I think this is a much better way to test whether your thing fits or not. So this is the way that I think about it. Okay, so now if we've passed all those previous stages and we haven't failed fast, we still feel like this might be a good opportunity, then we need to build with measured expansion, validating against our estimates. So if your idea proves to have opportunity, it may be worth starting to mine or build your business or your product or whatever. But we still must realize that just because our early experiments say there's opportunity, the overall idea may still prove to be a dud. Again, our samples might come out statistically significant. They might all be green, but when we actually go to build here, it's possible it just isn't right. So don't invest months and your entire war chest bringing in the heavy machinery. Instead, continue to expand with MVEs for changes, improvements, and new features, always validating the results against your expectations to maximize for the opportunity while guarding against investing in a dud. And I see this happen a lot where like people, they talk to customers like this, people want this thing. They're signing up to my thing. They're pre-purchasing. Let's like expand. Let's get a director of engineering. Let's get some VPs. Let's hire all these like big tech staff engineers, and they're bringing out the heavy machinery and they're expanding so fast. And then they actually, they build the thing, right? They spend months and all these resources building the perfect thing because they got this early validation. But at the end of the perfect thing with the heavy machinery, it's like, wait, it was just a weird sample. Like actually they don't care about this. They're not willing to pay for it. So this is why you need to continue validating your stuff. Like you can't just, there's no amount of evidence you can ever get to prove that you're right. You can only get evidence that proves that you're wrong. So don't act like you're 100% proven because you never will be. You need to make these constant small experiments to prevent yourself from going off in a wrong direction. And most directions are wrong. There's usually only a handful of directions that are like right, but you can only find that by finding the wrong one. And so this process of measured expansion, this is what I call the creation cycle. It's the observe, create, reflect loop. If you read my reflections, you'll notice that I basically organize like my entire life and all my projects and stuff in this loop because I've found this to be the pattern that fits most things. But it's also been explained in many forms. Like if you read the Lean Startup, also recommend this book. It's a little dated, but I think a lot of the core context apply. They have a similar loop that they talk about, which is the build, measure, learn loop. But the whole idea is like, you can't just build and assume you're right because you're mostly wrong. Most things are just wrong. What you have to do is you have to find this opportunity. You have to like create the actual experiment to test it. And then you actually need to look at the results and see what the results are, because it's very likely that you went from a good area with a lot of gold to just like a few feet over and there's no gold there. So you actually need to course correct there to figure out where do you need to go from here. For those interested, I've explained this a few times, but I should probably have like a newer explanation of the creation cycle. But basically it looks like this. You observe, this is the stage of like finding the mines. Then you create, maybe you do the sampling. Then you reflect to figure out where you should go from here. You observe, build your little mines, you reflect which ones are good or not, and then you figure out what next to go from here. That's the cycle. All right, next. So in the end, building a startup like mining is a game of odds. Our best bet is to make many small bets to validate our opportunities before we overinvest, we overreach, we pre-optimize, we pre-scale, all to our own ruin. Once we decide to invest, we should still iterate sustainably with conscious creation cycles to maximize our returns while minimizing our risk of ruin. AKA, we need to stay in the game so that we can make as many small bets as possible so that when we find one that's not a dud, we can invest and actually get the value out. If you like this post, you might be interested in these. I'll have these linked in the description. Escape the build trap the simple way, how I run my project backlogs with Trello, and my career as a software engineer so far. Anyway, that's it for this video. Thanks for watching, and I'll see you in the next one.